So for week 2, we're going to work on developing and designing geodatabases. And so, what's a geodatabase? I affectionately call it the tuna can, but basically it's this container, this structure for storing spatial data in tables. So in a geodatabase you can find feature classes, feature datasets, raster data, tables, and relational data sets. You can find topologies and networking. All different kinds of features and feature relationships can be stored in a geodatabase. The primary reason is that all your data can be stored in one place. It also compresses your data. Price has some other reasons for the benefits of using a geodatabase. In one of the Esri lectures I was looking at this weekend, it talked about making better maps. I know that sometimes when I am working with tables, a table will not operate correctly unless I put it in a geodatabase, so they have some kind of stabilizing aspect of spatial data. There's several types of databases. In Price, she has both personal geodatabases and file geodatabases. Personal geodatabases have the smallest storage capacity. They run on Access, and file geodatabases are preferred. I think personal geodatabases are kind of becoming less and less common. And then there's what are called multi-use geodatabase, and there's several types of those, and we'll talk about those very briefly. When it looks at, let's see, this multi-use geodatabases, there's many platforms that are called multi-user geodatabase. ArcSDE is one that runs with ArcGIS or ArcInfo, ArcServer software, and most of those, like I think there's Oracle and SQL Server, all of those are multi-user geodatabases. And so one of the benefits for choosing a type of geodatabase is the editing capability. So a personal geodatabase, it says, has that suffix MDB. A file geodatabase has a GDB. Both of them can have many single users, so that with a personal geodatabase you can look at very small data sets, and file geodatabases let you accommodate larger geodatabases, just I think it's up to a terabyte. You can have many people open and look at a geodatabase, but it really limits how many people can edit. So if I had a file geodatabase and I had 3 separate feature data sets, I could have 3 different people each editing one of the feature data sets. In a geodatabase, in a personal geodatabase, it will lock actually at the geodatabase level, so you can only supposedly have one person inside the geodatabase working on the data. With the multiple users, you can have many users working on the same data, and if you have versioning set up, then it won't lock the different editors out. So 5 people could be working on a street layer, and versioning will update who did what section and when it was done, so there's a timestamp involved with that. And when you hear enterprise geodatabase, that's a specific process in ArcGIS. So you can set up. There's even a tool in the toolbox setting up an enterprise geodatabase. But we're going to just be working with personal geodatabases today. Inside a geodatabase, you can have a lot of different attributes stored. So in a feature data set, you can have polygons, lines, and points, annotations, dimension information, route information. You can have relationship classes. So this is that one-to-many relationships, and it was kind of painful to set those up in ArcGIS without using a geodatabase. I think we did that in chapter 3 or 4 of Price, but there's a lot of benefits to doing it within a geodatabase. You can set up geometric networks, you can set up topologies, road networks, tables, rasters. You can save in your topologies, you can identify what kind of connection rules you have. You can store toolboxes. We did that in the model builder, and address locators for geocoding. So lots of things can be stored inside that geodatabase. When you look at a personal geodatabase, that upward limit is 2 gigabytes, and one of the things that happens is if people are working in a personal geodatabase, it actually, when you get close to about 1 gigabyte, the processing and loading capabilities just crawl. So that might be one thing, and I never thought to look at this until I ran into this information, is that students who can't quite understand why their stuff is so slow to load or why they're having such trouble, just to make sure they're not working in a personal geodatabase. One of the benefits, though, is because it runs on Access, you could do spatial joins or attribute joins outside of ArcGIS. And sometimes, as I said a little earlier, joining tables can be kind of unstable, especially working with census data, and those joins can be done on that attribute table on the outside, which makes it a lot nicer. If you're going to run an editor or enterprise geodatabase, you have to have ArcInfo or ArcEditor, and you need to be running ArcGIS Server. So just some limitations there. So going into this a little more detailed, a featured data set, remember that a featured data set is consists of features that are somewhat related. They have the same spatial reference. You can put in a geometric network. So let's say I'm looking at electric utilities, and I might have lines and connectors, but I can also create a network that will model the flow of that electricity. And networks are created with things called edges and junctions. So the line work would be the edge, and the connections would be the junctions. And those setting up those topologies so that your junctions have to actually connect to each other. You can't have gaps or overlaps when you do your geometric networks. Geometric networks are different from transportation networks because geometric networks, the assumed flow is one way, and usually it's looking at a gravitational flow in terms of water or streams. So roads is incorrect in here. Let me get that out of there. Sorry. And with roads, the assumption is a road can go 2 directions. Not always. You can have a limitation on a road, but you could have traffic go both ways. And so transportation networks are run through network analysis extensions. You don't have to have the network analysis extension to run or to create a geometric network. And then in featured data sets, you can have topologies. And so here's an example of political boundaries in Iran that has a topology feature with that. So you have an administrative polygon, an Iran boundary polygon, annotations, and then this topology tool, which means that if I edit one of the vertices in the administration polygon, let's say I move that vertice east 50 feet, the coincident polygon on the west will move with it. In a geodatabase, you can define what are called domains or specific attribute data related to fields in your feature classes. So one reason for defining attribute domains is that it makes your data more correct or more accurate, ensures integrity. So I can set 10 diameter ranges so that people don't inadvertently input incorrect information. So you can have domains that have range values or coded values. So a range value says my diameters of my pipes are going to be from 0.3 to 0.5, so, or 0.3 to 5. So if I accidentally type in 0.2, it won't let me enter that information. Coded values are you identify the specific code types. So for example, I might have in a land use file, I would identify it as text and a coded value, and I would have be able to indicate that in my land use fields, if it says R, it means residential. If it says RR, it's rural residential, and on down. So you'll get a lot of practice with setting up those domains. You can also set up some behavior rules like split and merge, and that's useful for updating features. So let's say I have a road or a parcel and I need to split a section of it. There's been a landslide and we've lost a piece of the highway and we're not going to rebuild it, so I need to kind of split that road where the landslide occurred, and then I need the geometry or the attributes to update, and I can set those values whether I want to take a default value, which is the original value. No, the default value is something that I identify. I can have if I split a polygon or a line, I can give both the new line and the old line will have the original attributes, or I can use something like a size ratio. So if I divide a polygon 20-80% and the value was 100,000 in the beginning, then after I divide it, the value in the area that's 20% will be 20,000, and the value in the area that's 80% will be 80,000. There's also a merge feature that allows you to combine features, and then with that there are several options whether you want to have the value fields, if there are value fields, sum, or do you want to do a weighted average, which means kind of based on the area of each piece that's being merged. Do you want that to inform the value? So lots of options for updating, creating, and managing data. You can also define subtypes. So once you define your domains, you have to go into the feature class. The domains are defined in the Geodatabase, and then you go into your feature classes within your Geodatabase, and you assign different categorical information. So subtypes are always categorical. So let's say I have a feature class called water lines, and I want to create a subtype of water line. One subtype is a main and the other subtype is a lateral. So that's just like categorical data. But what I can do in subtypes is set some of the default characteristics for each of these water lines. So I could say I want the every time I create or split a water main, I want the size to be filled in as 6 inches and the material to be filled in as PVC. So I don't have to update those attributes every time I create a new water line. Same can be with roads. The other thing that you can do in a Geodatabase is set up relationship classes, and this kind of helps you update those relationships and manage them. You can delete them, update them all easily, and you'll see a lot of relationship classes in some examples I have for you. And finally, you can do set up annotations. And remember, we did some annotations in one of the earlier chapters, and so the annotation is actually a scalable feature, and so you can store those in here. When you get ready to design a geodatabase, people talk about that as the data model or the schema, and basically it's kind of just the structure. You know, what tables are you going to have? What fields? How are these things going to relate? What are your domains? And some places provide what's called a data dictionary that just gives you this whole list of feature types and data within your data model. So you're not going to be able to see this. I tried to find one that was more readable, but this is a very common looking data model. So this is for marine exploration, I believe. And so what you see is probably all you can see are boxes, but they and lines, and a lot of these are done in Visio that just kind of show you the relationships between different data, and then here's the expanded geodatabase. So I went into let's see if I can find that. I went into ArcGIS and I looked for some examples, and so some companies provide empty data models. So here is a Forest Service data model, or for their GIS data. So they only have, this is so interesting to me, they have only one feature data set, and that's called ownership. And the ownership has topology rules with it. And I think there's really no data involved in this. If I go to table, yeah, I think these are empty. So they've just created all of the structures for you. But there is, well, let's see. I'm going to go to geography on that. I guess there is some information. Interesting. But I think a lot of these are empty. So they've got forest boundaries, and then they've got tables for all of the fields that would be in their tables. They have relationship classes, so prescriptions to prescriptions that have forest stands. Here's another relationship class: restocking, riparian zones, rights, and another table with a pivot table with species in it, and many more relationship classes. So this is an example of the detail that's used. Let me go back over here. And so here's the download I got. So there's the geodatabase. But here is their logical design. And I'll see if we can see. Oh, that showed up a minute ago. Dang it. Oh, there it is. Okay. So, and I've not, oh, here we go. Let's see if I can go to 150%. So they're in designing their geodatabase, they are very detailed about the type of field. So material is an integer, a subtype. They've got the diameter, the length. So what is this? This is the road infrastructure. Then they have more information here, more subtypes, forest trails. There was a list somewhere down here of all the different all the different domains. So I guess what I wanted to say about this is developing and designing a geodatabase takes a lot of planning, and setting up the domains and the subtypes is a little bit cumbersome, but once you do it, it can really facilitate easier work. So as to the tutorial, let me see if I can find my ArcGIS again. Here we go. I think she has you do all of the database design in Arc Catalog, and so I was going through this myself, and there was one thing that I just wanted to show you because I think it can save you a little bit of headache. I was working in Rapid City. So she had me create 4 feature data sets, and then inside each of the feature data sets I imported, created, copied and pasted different feature classes. And if I look into my Geodatabase, in the domains tab, this is where I set up the domains. And so I had one called diameter, pipe diameter. I chose that it's short integer, coded value. These are the codes, and I got lazy and didn't type inch after here. So here's another for road directions, and it's text coded, and road directions are there, pipe material. So I set all of these up earlier. Now, one of the things that happens is if I'm going to start a new domain, I'm going to put it here. So this is actually no spaces are allowed on this side. Type of road, and then over here, oh, I already have that. How about type surface? And then over here I can type okay, so I'm going to make that some kind of text, and I want to make it coded. And asphalt, whoops, maybe let's do P for paved, D for dirt. Now, one of the things that can happen is that I can be typing in here but not have that selected. So actually I've maybe made a mistake and clicked down below here. I set that, and I set that to text, and I set coded values, and I started putting in my codes here, but I'm not really connected to one of the domains. So just make sure that you've got that selected and before you start working, or your stuff gets totally messed up. So you're going to set up your domains, and then you'll go into some of your let's see, was it the water lines? I think so. In the water lines properties, I went into the water lines, and in fields I might have created a new field. One of these you create a new field, but then in my subtypes I created 4 subtypes. So for my water main, I typed in a subtype, and that's my default. Most everything's going to be a water main, so I left it there. But I can set up my default diameter, my default pipe material, and the maximum flow in here. And you make a connection between your feature class and your domains. Let's see, where did I do that? Let's go to, maybe I did that in roads. Properties. So if I go to fields here, oh, maybe not. Yes. And I click on suffix. Right here, suffix, the domain for suffix is abbreviation. So I can set that right here. And I think prefix also had a domain that I set, was direction. So just be really careful when you go through price that you're setting these up correctly, and then when you start to work through editing things using these relationships, I think it works pretty well. Okay, tutorial is due at the end of class on Thursday.